All right, welcome to worksheet number 8, derivative of trig functions. This corresponds to the book section number 2.4. Last few sections we talked about how to find the derivative of different functions like x squared, x plus 1, whatever, 1 over x. Here we'll learn how to find the derivative of various trig functions. Trig functions like sine, cosine, and tangent, and all that stuff. Also, I want to kind of tell you that you want to review your unit circles so you can easily calculate sines and cosines of various angles, such as like sine of 0, sine of pi over 4, cosine of pi over 2, all that stuff. That'll help you. That'll make your life a little bit easier throughout the semester. Okay, let's look at the first example. Again, limit question here. I want to evaluate the limit as theta goes to 0, sine theta over 0. Again, my initial reaction is like, oh, can I just plug in 0? So sine 0 over 0. We know that sine 0 is equal to 0, so we get 0 over 0 case. Again, like that means we need to have a further investigation to figure out what the limit is. So let's kind of try the numerical method. Let's just plug in a bunch of numbers and see what we get. So here I'm going to just plug in various numbers, 0.1 and so on and so forth. Here I want to make sure that your calculator is in radian mode. Calculator needs to be in radian mode. How do I know that? If you do sine 90, and if your answer is 1, that means you're not in radian mode. Not in radian mode. So that means you need to change that. So make sure, try sine of 90. If it gives you 1, you need to change that. If it gives you 0.89 something, then you're in good shape. So once you plug in these numbers, I'll get 0.99833, so on and so forth, 0.99998, 0.99999. So you can kind of see it approaches to 1, and actually that's the limit. So we'll use that later. So sine theta over theta is 0 over 0. It turned out to be 1. We can kind of do the same thing for example 2. If you calculate this one out, you're going to get 0 as an answer. We'll use the sine over theta more often than this. Sometimes I don't remember this part, but this one definitely we're going to be using a bunch of times later on. All right, let's look at the example 3. Example 3. I want to find the derivative. So I want to find f prime of x when f of x is sine x by using the limit of definition of the derivative. Here, hint is use the trig identity here. Okay, so let's see how it works. First, I'm going to write out the definition of the derivative. F prime is limit f of x plus h. I'll use this one over h as h goes to 0. Here our function is sine x. So let's kind of rewrite this in terms of sine. So I get limit h goes to 0 sine x plus h minus sine of x over h. Okay. Here I notice sine something plus something here. There's a hint. I'll use the trig identity here. I can rewrite this into some more complicated stuff. So let's see if that's going to help us out. Limit h goes to 0. So in this case, my a is x and then b is h. So I can rewrite that as sine of the first one, cosine of the second one, plus sine of the second one, which is h, times cosine of the first one, which is x, and then minus sine x over all over h. So here, let me kind of put the parentheses here. So and it's slightly complicated. This part, I'm just using this identity. So instead of using a and b, I use x and h, and I use h and x, right? So that. All right, so what's next? It looks complicated. What I'm going to do next is, I see the term with the sine x in it. I see the term with the sine x in it, so maybe I can factor that out. So let's see, I can do limit sine x cosine h minus 1 plus sine h cosine x all over h. All right, next I'm going to split the limit. So it's going to be like sine x cosine h minus 1 over h plus sine h cosine x over h. both limit h goes to 0. Okay, so now let's look at the formula that we had before. First, I noticed that, this one I noticed that there's a cosine h minus 1 over h part. That's cosine theta minus 1 over theta as theta goes to 0. Cosine h minus 1 over h as h goes to 0. So this part goes to 0, right? And then how about the second portion? I noticed the sine h over h as h goes to 0. That was the first thing we talked about, where is sine of theta over theta as theta goes to 0. So theta, 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 theta goes to 0, right? They're all matching. And the answer is 1. So that will be the second part, where here now, instead of theta, I have h, h, h. They're all matching. So this part goes to 1. Whereas the first part, cosine minus 1 over h, that goes to 0. So having said that, so this part goes to 0. So this part goes to 0 according to the previous formula. And this part goes to 1. All right, so what do you get? The first part is just 0 because it's basically 0 times sine x. So that's 0. Plus, second part, this is 1. So 1 times cosine x is just cosine x. H goes to 0, so this does nothing to x. So if I calculate this limit, it's just 1. Cosine x doesn't have h in it, so just x is just x. Cosine x. Wow. So okay, that's my final answer here. So we kind of went through complicated stuff, but when you take the derivative of the sine x, and then as an answer, you get cosine of x. So let me write that down here. So derivative, this is our formula, derivative of d dx sine x is cosine x. And I'm not going to go through the detailed stuff, but when you take the derivative of cosine, what you get is negative sine x, right? These two formula very, very important. So I want to make sure you guys remember this part. Let me highlight here. Let me highlight it here. All right, let's look at the next example then. Example 4. Find the derivative. I'll do a few, and then I'm going to have you try a bunch of them, okay? Let's do the first one. Find the derivative of, we have x squared plus sine x minus 3 cosine x. All right, so f prime of x is, so we have 3 things added. So when things are added, it's pretty easy. I mean, it's easier. I just do it each one separately and then add them answer. So x squared 2x to the 1 power. So power rule, so the exponent comes down and you subtract the exponent by 1. So I got that. Second term is sine x. We just learned that that's the derivative of sine is cosine x. And then minus 3 cosine x. Again, derivative of cosine is negative sine. So negative 3 and then negative, that'll make it positive. Sine x. So as you can see, sometimes I forget the negative for cosine. So just remember that derivative of cosine has negative in it. And then for you later on, you'll realize that of the trig function that has cos something, it starts with cos something, the derivative will have a negative sign in it. So just remember that. Let me do one more. Maybe I'll do part C, and then I'll have you finish the rest of it. Part C, it has cosine and then over x squared minus 1. So here I'm going to use the quotient rule. I have something over something. So just refresh my memory. F over g prime is f prime g minus f g prime over g squared. Whereas in this case, my f is going to be cosine, my g is going to be x plus 1. So how does that work? So this is going to be h prime is going to be derivative. First thing is the derivative of the top times the bottom. So derivative of the top is cosine. Derivative of cosine is negative sine times the bottom. All right. And then minus. So write the minus here. And then I have just the top, no derivative. And then times the derivative of the bottom. So I write cosine x times the derivative of bottom. Bottom is x squared plus 1. The derivative is 2x plus 0 because derivative of 1 is just a 0. So just 2x. Okay. All over the bottom part square. So like this. Sometimes, especially with the quotient rule, your answer is complicated. There's no easy way to simplify this, so I'll just leave my answer as is here. Okay. Now I'm going to have you try part B and part D. And once you're done with that, we'll meet at the next question. Okay. All right. So if you're done with B and D, if you're going to check your answer for part B, the answer should be negative sine square plus cosine square. Again, in terms of notation, sine, when you see sine square x like this basically means sine x squared, which means sine x times sine x, right? So this here, we kind of use our notation slightly differently. For sine square or cosine square, we put the square here, it just means sine x squared, which is different than, so here, just another comment, which is different from sine x squared, means sine of x squared, right? So it kind of matters, like, are you squaring just the x? Then this is a notation. So the notation at the top is square just x, square just x. Whereas here, you square entire sine x. Right? So it depends on which one you're squaring. So notation is a little weird, but same here. Cosine square x means cosine x times cosine x. All right, so that's the answer for part B. For part D, the answer should be 1 over cosine squared. Again, 1 over cosine squared means 1 over cosine times cosine x, right? Which is also secant squared. Here I'm using the fact that as one of the trig identity, secant x just means 1 over cosine x, right? And cosecant x means 1 over sine x. So let's just get a different name. So literally secant x means 1 over cosine. So 1 over cosine square is secant square. All right, let's look at the other formulas for the trig function. So far we had derivative of sine x is cosine x. Derivative of cosine x is negative sine x. How about tangent x? Derivative of tangent x is secant squared x. Again, here, make a note here, tangent x comes from sine x over cosine x. And then next one, derivative of a secant x is secant x times tangent x. Derivative of cosecant x, the next one. Again, it starts with co something, so as I said before, it starts with negative something. So negative cosecant times cotangent x. Then the last one, derivative of cotangent x is negative cosecant squared x. Wow. So there's a lot of stuff, as you can see. So we have this, we have this, we have 6 different derivatives. So I have this, and I have this, and I have this. For sure, sine, cosine, tangent, we'll use that a lot. Even the secant, so these 4 we'll use a lot. So for sure, you want to remember that. Sometimes I'm a little iffy on this, but if you remember this, your life is going to be pretty, it'll make your life pretty easy. Again, if it starts with cosine or cotangent or cosecant, it'll have a negative derivative. Okay, so that's what the next statement says. All co-functions have a negative derivative. Okay, all right, let's look at example 5. Find the derivative if f of x is x squared times secant x. Okay, so this is, again, it's going to be f times g. So this is the product rule I'm going to be using. So this means it's f prime g plus f g prime, right? The derivative of the first term, x squared, derivative is 2x times the second one, just leave it as it is, secant x plus f, which is just don't take the derivative of the first term, so just leave it as it is, x squared times the derivative of the second one. So derivative of secant was the derivative of secant is secant tangent. So secant tangent. Now let's get example 6. Find the Second derivative if f is this. Okay, fine. So just have to take the derivative twice. Let's see what happens. First, f prime of x. Again, f is secant. Derivative of secant is secant tangent. So secant tangent. So that's my only first derivative. So now I want to do the second derivative. Okay, so I kind of do the same thing. It's product of two things, right? So this will be f prime times g plus f g prime. I'm going to have a feeling this is going to be a little bit more complicated than the other ones. So derivative of, wow, okay. So this is my first one. So f prime, so take the derivative of the secant. I think we just did it. Yeah, so it says secant tangent. So secant tangent. So that's the f prime part. And then g, leave the second part as is, tangent x, plus, now leave the first one as is, so times, take the derivative of the second part. So what was the derivative of the tangent? It's the secant squared. So secant squared. All right. Here I can kind of see this one has a secant in it, this one has a secant in it, so maybe we can factor that out. So there's secant and then tangent squared plus secant squared. All right, let's look at the next question here. Find the slope of the tangent line of this function at pi over 4. So, okay, we did the slope of the tangent line before. It's just another way of saying to find the derivative. Here they give you a particular point, so I'll take the derivative of this, and I'll just plug in x as pi over 4. Let's see what happens. So f prime of x is equal to, I have two things multiplied, so I kind of do the same thing, f prime g f g prime. So take the derivative of first term. So first term is just x. Derivative of x is just 1 times, leave the second one as is. F, so leave the first one as is, don't take the derivative, and then derivative of tangent is the second part, secant squared. Okay, so now at x is equal to pi over 4, so we'll get 1 times tangent pi over 4 plus pi over 4 times secant squared. Again, we know that secant squared is 1 over cosine squared, pi over 4. Okay, let me rewrite it one more time. I noticed that there's tangent. I know tangent is sine over cosine. So let me write it like so. It's 1 times that, so I'll just write sine pi over 4 over cosine pi over 4 plus pi over 4, 1 over cosine squared pi over 4. All right, so sine pi over 4 is radical 2 over 2. Cosine pi over 4 is radical 2 over 2 plus pi over 4 times 1 over, again, cosine pi over 4 is radical 2 over 2, and then square. Here, again, I have to be super careful. I'm not squaring pi over 4. This notation means take the cosine pi over 2, pi over 4, get the answer, and then square the answer, right? All right, so the first one, pi over 2, there's simplify 1, because it's the same thing on top and same thing on the bottom. Pi over 4 times, this will, radical 2 over 2 square is 2 over 4, so that's basically just 1/2. 1 over that, so it'll be 2 over 1. Yay, 1 plus, so I can cancel this out, pi over 2. Yikes. All right, so that's the answer. I'm going to have you try number 8. Kind of similar, find the equation of the tangent line. So again, I'm going to kind of do the same process to get the slope. And then what point are they talking about? Here, point is 0. So what happens when you plug in 0 into x? Whatever you get is y, so you have a point. So you can get the equation of tangent line. That means you know you get a slope, and then you have a point, and you'll use those to get the y. So your answer should look like something like y is equal to mx plus b. And for example 8, if you're done, the answer should be y is equal to -1/4 x plus 1/2. So it goes through 0.012, and then slope should be negative 1/4. Let's look at the last few questions here. These are the limit questions. Oh, limit with the sign. I thought we already did something like this. So I'm going to remind, like, what was it that we did in the beginning? Is the limit of theta goes to 0. Sine theta over theta is equal to 1. So, like here they use theta, but I could have used x or h or whatever. It doesn't matter. As long as these letters all match, then the limit is equal to 1. Here, it kind of looks like this, but the only problem is there's a 5. So I'm like, well, they have to be exactly matching, right? X is going to 0, but here is 5x and there's x. So they're kind of different. So there's a little trick I'm going to have to do. The limit. So I'm going to try to make it look exactly like this. This variable has to match exactly that. So 5 and 5x and x, they're similar. So this is what I'm going to do. Sine 5x. I want to have 5x on the bottom. So what I'll do is I'll multiply 5 on the bottom. And that means I need to multiply 5 on the top as well. Just like this, right? So I multiply 5 on the bottom, I multiply 5 on the top. So I'm not really changing anything, except now it looks like I have 5x on the bottom. So here I can say this part will go to 1. So h equals to 0, 5x and 5x, these two matches. Yay. And then that goes to 0 because h goes to 0, 5x goes to also 0. So then I get 1 times 5 over 1, which is just a 5. Okay. And example 10, I have this, sine 4x and sine 6x. Where's my x? So again, I'm going to just have to kind of create my own, or just multiply same thing on the top and bottom. So I did that. So the reason I did this is because I have sine 4x. So I kind of want to have 4x on the bottom. So these two will be, the limit is going to, these two will give you limit 1. And also I'm going to take care of 6x as well. So 6x, 6x. So like this one and this one will get you the 1 as a limit. So let me rewrite this. Sine 4x over 4x. 6x over sine 6x. Times, so I took care of this one, and then I took care of this one, so I have extra 4x on the top, extra 6x on the bottom. So I just reorganized it. The reason I did it is because this will give you 1. This will also give you 1 because it's a reciprocal of something that has 1, so the limit is 1 over 1, which is also 1. So this will go, limit is 1 times 1 over 1, which is just 1. And then limit 4x over 6x as x goes to 0. That'll go 4 over 6, which is 2 over 3. This is my final answer. All right, I think that's it for this section.